Every second, 29,000 people ask ChatGPT a question. That's not a peak, that's Tuesday. 700 million weekly users. 5 billion queries every single day. And every one of them hits infrastructure that barely existed 3 years ago. Behind your chat box is a $100 billion machine. And it's nothing like a server farm from 2015. When you type a message, it gets shredded. Not stored, shredded into tokens. The word data center becomes 3 fragments. ChatGPT never sees your sentence, it sees numbers. Thousands of them. Those numbers land inside a GPU node. Not a CPU. A GPU. Because a CPU executes one task brilliantly, a GPU executes 16,000 tasks simultaneously. One H100 GPU holds 80 gigabytes of high-bandwidth memory, and each node packs 8 of them together. Those 8 GPUs aren't separate devices. They're fused by NVLink, NVIDIA proprietary interconnect running at 900 gigabytes per second. For reference, a USB-C port runs at 40 gigabytes per second. NVLink is 22 times faster. Within a node, the GPUs share memory as if they are one brain. But one node isn't enough. Training GPT-4 required 25,000 A100 GPUs across thousands of nodes. Between nodes, data moves over InfiniBand, a network so fast it can move 400 gigabytes between 2 machines in 1 second. That's your entire Steam library. Every second. Training took 90 to 100 days. 25,000 GPUs, never stopping. The cluster consumed roughly 50 megawatts, enough electricity for 40,000 homes, continuously for 3 months. The dataset alone had 13 trillion tokens. You can't fit GPT-4 on one machine. So OpenAI splits it 3 ways. Tensor Parallelism splits individual matrix operations across GPUs. Pipeline Parallelism layers the model like an assembly line. Data Parallelism clones the entire model to run different batches in parallel. All 3 run simultaneously. Here's the dirty secret. Every 15 seconds during training, every GPU must stop and synchronize gradients with every other GPU. On 25,000 nodes, that all-reduce operation is the single biggest bottleneck. Nodes sitting idle, waiting. A coordination tax on every forward pass. When you chat with ChatGPT, you're not in training anymore, you're in inference. And inference has 2 distinct phases. Phase 1, Prefill. The model reads your entire prompt in one shot and generates 1 token. Phase 2, Decode. It generates each subsequent token one at a time, each depending on everything before it. Every token it generates needs to attend to every previous token. That's the attention mechanism. And to avoid recomputing attention from scratch each step, the model stores a KV cache, key-value pairs, for every previous token. For a long conversation with GPT-496 attention heads, that cache can hit 400 gigabytes. That's 5 entire H100 GPUs just for memory. But OpenAI doesn't allocate 400 gigabytes per user. vLLM, the inference engine used at scale, uses paged attention, borrowing the same idea as virtual memory in operating systems. Memory is allocated in fixed pages, shared across users, swapped as needed. One physical GPU can simultaneously serve dozens of conversations. ChatGPT uses about 34 watt-hours per query. Multiply that by 5 billion queries per day and you get 850 megawatt-hours daily, enough to charge 5,000 electric vehicles every single day. And that's the cheap model. GPT-5 averages 18 watt-hours per query. OpenAI, Microsoft, and their partners are spending $100 billion on the Stargate project, the largest AI infrastructure build-out in history. One facility alone will draw more power than the entire city of Los Angeles. Traditional air cooling can't remove enough heat from a rack dense with H100. So the new generation of AI data centers uses direct liquid cooling, running chilled water directly past the chips. It enables 4x higher power density per rack. By 2030, nearly 3,000 AI data centers are planned globally at a combined investment of $7 trillion. AI power capacity today is already comparable to the peak electricity demand of New York State. The next time you press enter on a ChatGPT message, you're triggering a chain reaction across tens of thousands of GPUs, petabytes of memory, and enough electricity to power a small city. And it responds in under 2 seconds. If you found this useful, subscribe. 1 video every week, 1 system at a time.